All right, we're now going to add DirectX to our video game. We're going to do it in 3 steps. First, we're going to rejigger our update loop to be appropriate for calling DirectX and clearing the screen every frame. Then we're going to initialize and create our DirectX objects. And then finally, we're going to go through the steps to clear and then render a scene. So the first off, we're going to go ahead and set up our DirectX system. And whenever I set up a system, before I even know what I'm doing, I tend to write 3 functions. A function called init, a function called update, and a function called dispose. Update and dispose. And then I figure out where I want to put these 3 calls, like where to in the code do I want to be initting, shutting down, and updating whatever system I'm using. And I think here, right after I create the window, it seems very reasonable to initialize DirectX. Right after, before we exit, seems good to dispose of DirectX. And then it gets a little fuzzy here. When do we want to update our DirectX system? And just for clarity, often I turn these update functions when they're having to do with graphics, I call them draw functions to differentiate them from simulation. So first idea of where we might put our draw function is here in the middle of our while loop. There's a slight issue with this though. Get message, this call that gets the message from the Windows operating system, is what's known as blocking. It means this function call won't return until there's a message. So while nothing is going on, you're not going to be drawing. You're just going to be stuck here waiting for a message to come back. So a pretty common technique is to go back to what we were talking about before and put an infinite loop around this and do something like this. Now, all the time we'll be drawing, every time possible we'll be drawing if we can change this to be what a non-blocking function call. Turns out there's a non-blocking get message called peak message, and it, instead of waiting for the message, it just checks to see if there's a message there. If there is, it will return true and we'll do something with it. If it won't, it will return false and will fall through and we'll draw. So let's go look up peak message. It's pretty much the same as get message, except with the same filtering parameters that we're not interested in. But this last one parameter specifies what to do when we get a message, and what we want to do is go ahead and remove the message. So we will check out if there's a message. If there is, remove it, and then translate and dispatch it. Go ahead and handle it. You'll note now that the get message used to handle the quit for us. Now we have to handle the quit ourselves. So if message equals quit message, we'll break out of here and fall down to the dispose. All right, let's try that. Even though our functions aren't really doing anything, in theory, we should have exactly the same functionality we had before with our DX draw call happening every frame. So we're going to go ahead and compile. All the same Windows things are working, and if we put a breakpoint here, we're hitting it pretty much as fast as we possibly can. All right, and then we quit and we actually exit the program. Pretty good. Okay, in the next section, we'll go ahead and initialize DirectX.